Welcome everybody to this talk about Grails 3 plugins. My name is Álvaro Sánchez. I work at OCI as part of the Grails development team. Graham already told you what we do. I wouldn't do it again. There's my email if you want to reach out to me, my Twitter handle. So if you have any questions during the conference, you can talk to me. I'll be here all day. So this session is about Grails 3 plugins. So how many of you are using Grails 3 already? Okay, quite a few. So out of which, how many are using Grails 3.1? Less than that, okay. So the plugin system in Grails 3 is quite similar to the one in Grails 2, but there are a few differences. And what I'm going to take you is essentially what is new in the Grails 3 system. So what are the new options you have, and also a few tips, for you to create plugins. That's the idea. So to start creating a Grails plugin, you can use the create plugin command. When you don't specify anything, so there's essentially two options. You can specify a profile. Graham already told you about the profiles. So at the moment, there are a couple of profiles for plugins. One is the web plugin, and the other one is the plugin, just plugin. So a profile defines essentially how your build.grails is generated. So this is something Graham told you already. Depending on the profile descriptor, the dependencies and the build plugins that are on your created projects, you will get a build.grails file for you. A profile also provides you commands like create the main class or run app and things like that, and features as well. Can you hear me? Hello? Working? Okay. And also features like the Hibernate, JSON views or markup views or whatever. You also know that the features are optional or required depending on the profile descriptor file. And finally, the skeleton. The skeleton is essentially wherever you want to put in a profile will be part of your newly created application. So for instance, there is a base profile. And there is one thing wasn't mentioned before, but there is a hierarchy of profiles. So there is a base profile. And then, for instance, the REST API profile is, let's say, extending the base profile, right? And you can create new profiles and extend on existing ones if you want, right? Or even combine two profiles into a single one. So that's quite flexible. And the skeleton is everything you want to put there. So for instance, the Grails app folder with the services, controllers, views, that's the default skeleton you get is part of the skeleton of the profile, right? So the differences between a plugin profile and a web plugin profile, remember that the web plugin is the default option. It's essentially the dependencies you get. So essentially, web plugin is meant to be used in a web application. So you have dependencies for, for instance, the Tomcat, Spring Boot Starter, the cache plugin, scaffolding plugin, Jeff for testing, and things like that. Whereas in the plugin profile, you don't, right? So you created your application using a profile, in this case is a plugin, you get a bunch of things. But the next step is to trim your plugin. So keep it clean, right? This is the first advice I'm giving you. So whenever possible, use the plugin profile. There might be content you are not going to use. So for instance, if your plugin is not using any controller, remove that folder, right? You might have files you're not going to use as well, right? And if you don't do this, there is a bot in the internet called Barbecue, and he will send you a pull request. So how many of you have received a pull request from Barbecue? Bart, are you here? He's not? Okay. So yeah, this is the kind of the things that the bot is doing. So he will essentially detect when a plugin is messy because you didn't do your job and you didn't clean the things, and you're providing a bunch of folders that are not needed. So he will detect that and send you a pull request. This is amazing because I took a look at the GitHub API, and over the last 3 months, he sent 14 pull requests. But this is only because the GitHub API is only a 3-month timeline. So I don't know what he did in the past, but probably hundreds. So we never know. So we have a tidy plugin ecosystem thanks to Bert. So applause for Bert. But other than cleaning the profile, another thing you have to watch out is things you include in the profile. For instance, dependencies you support. So whatever you have to think about your plugin, especially if it's a public one, will be used by people. And if your plugin has dependencies like transitive dependencies, your application user will receive them. So keep that really carefully. And for instance, if you're using any library, you should check that library dependencies because of the transitive dependency resolution, you will get all that library dependencies, and maybe you don't want them, right? So do that carefully. So imagine you want to start like the cleanest way possible. So a plugin is essentially a jar file. It's a basically Gradle-based project. So the minimal plugin would be a folder or carpet, as I used to say, containing a build.gradle file, a simple directory associated main Groovy with the plugin descriptor, which I will explain later, and an empty Grails app folder. This is because expectation of the Grails build system, but we might remove that in the future. So the plugin descriptor, there's nothing else than a class inside associated main Groovy. Is a class that extends Grails.plugins.plugin. It can override methods to define behavior in the plugin lifecycle. So, for instance, the lifecycle points you're used to see in Grails 2 are also in Grails 3. So, do with dynamic methods or do with web descriptor. They are there. The syntax has changed a little bit from Grails 2. Because in Grails 2, essentially the plugin descriptor was a script. Well, it wasn't a script; it was a class, but it was in the root folder of your plugin. That's not anymore because this is a standard Gradle-based project. So that's a normal class, and it's a normal class extending an interface, right? In this case, it's Grails.plugins.plugin. So you will have a standard method overrides, and the methods, for instance, are returning closures. Whereas in Grails 2, what you have is essentially public closures, literally on the class, right? Nothing else. So now it's simply methods, returning closures, and you're done, but everything else is more or less the same. So some features or things you can do with plugins. So regarding configuration, a plugin can define, configuration values you're wanting to support to the application, to the Grails application that will use your plugin, right? How do you do that? But you have two options. You can use plugin.yaml or plugin.groovy. One of the two, but not both. When to use one and when to use the other one? My advice is that you should use plugin.yaml unless there's something, some configuration value that is impossible to represent on a YAML file. For instance, a closure value, right? So if there is a particular configuration property that is like a closure, then use plugin.groovy. The values you define there will be exported to the application. Or said in a different way, when the host application with your plugin installed is starting up, Grails will merge the values of your plugin.groovy with the application configuration files, right? So it will be the runtime configuration of your application will be a combination of both. The other option is configuration values that are for your plugin development, but not for the application itself. And for that case, you have the normal application.yaml and application.groovy. This is the same as in any Grails application, because I didn't tell you, but I'm telling you now that the Grails plugin is a Grails application as well, right? The only thing you have to think about is if you're creating a plugin with the plugin profile, your plugin is not runnable. Why? Because there's no Tomcat thing, so there's nothing to run, right? So, however, if you use the web plugin profile, right, then you can run like a run app and have everything there. And in that case, this is the standard configuration, right? But those files are not exported to the application installing your plugin. There might be the chance that you need to exclude some content for the final application. For instance, if you have test controllers or test domain classes, things that are for your internal development but not for the application to be used, you have to exclude it. So inside the plugin descriptor, there is a property you can define with is a list of elements to exclude from the packaging. The difference is that in Grails 3, you also have to provide a small snippet as part of the build.gradle file with the jar command. So the jar block is essentially a standard build.gradle configuration block, right? And you're excluding that from being packaged as part of your plugin, jar file. There are also command line extensions as part of the plugins. So there are two things here you can use. One is create a script. So scripts are code generation commands, or are for code generation. Those are just runnable with the Grails CLI. So when you type Grails and then something else, then you can use those scripts for instance, generate views or something like that. It's called generation, right? The other option is the create command. A command is to interact with the loaded or running or bootstrapped Grails application. And those commands are runnable with the Grails CLI or as a Gradle task. So the first case is a script. Is a plain Groovy script. The base class is not specified, as I'm telling you. So every script is set a base class of a Groovy script command, which means that there are, for instance, the description method. I don't know if the pointer is working. The description method is part of the Groovy script command base class, right? That is where you define, for instance, if there is an argument or not, if the argument can be completed or not. So this is literally the generate all command from the base profile, right? And what you see is that, well, a part of the description method, this is the actual code of the script, and it's invoking methods that are not present here, which essentially will run other scripts. So you can have scripts that are running other scripts. Because there is a generate controller, generate views, generate unit test. So generate all basically calls them all in a particular order, right? The other option is a Grails command. So this is completely different because this is essentially a class implementing an interface. The interface is essentially giving you access to the Spring, to the runnable or bootstrapped Spring application context. So what you do is you grab a bin from the application context and do whatever you want, right? So you can assume that the Spring context has been fully loaded by this time. There's nothing to... there was much worse to do with Grails 2 because you have to mess with the internal Grails stages to load the application. The Boolean value is the result of your execution. So to tell the Grails CLI whether the execution of the command succeeded or not, then there's a Boolean value. There might be also the chance that you want to enhance artifacts. And this was used to be done using metaprogramming in Grails 2. So if you remember, for instance, if you want to add a particular method to a controller, what you would do in Grails 2 is use the do with dynamic methods closure. And you would say, OK, give me all the controllers, and for each one, then controller class dot meta class dot whatever method equals closure, blah, blah, blah. That's Grails 2. In Grails 3, this is completely different. So first of all, what we have here is a trait. Do you guys know what a trait is? So traits are essentially like interface with the default method, kind of. And they are designed to be applied into existing classes. In this particular case, this trait is annotated with an annotation called enhances. And there is a list of Grails artifacts that the trait is enhancing. So apart from this, there is an internal Grails API called the trait injector API. So basically, that's going to look traits annotated with this annotation, with enhances, and will do all the trait injection for you, right? So we'll iterate over all the controllers and all the services in your class, and we'll add this trait to them. The great thing is that there's no runtime metaprogramming involved anymore. This is compile time metaprogramming. Even you can annotate your new methods with compile static, which is great, right? Well, so say that you have been creating a successful plugin and it's growing and growing and growing. So there will be a point where you have to modularize it. Because otherwise you might end up creating a monolith. So the principles behind the, when you think about it, you're creating an application, it becomes big. And you think that it's time to break it down. You can follow the same ideas to your plugins, right? And this is essentially the difference between a monolithic plugin and a multi-module plugin, right? So you do shit, it will be the same shit in smaller parts, but it will be reusable, right? So it's much better for this. I had to put this slide because it is probably the most famous slide I've created ever. And I had to create, the argument of the presentation so that I could pass over here. But really, so there are many benefits for you to modularize. So one is the optional dependencies. You have to think about that when you create a plugin, as I told you, it's a Gradle jar file, right, with a dependency resolution. So when a user is installing your plugin in the build Gradle, it will fetch your transitive dependencies, right? And you have to be careful with that. You shouldn't pollute people's class path with something you don't really need. So imagine you're writing a plugin with, for instance, you have different storages, and you support either MongoDB or Redis or Gorm or something like that. But the user is likely to use only one at a time. So if you weren't doing different modules, what you would do is your single plugin will have to have all the dependencies. The Redis client, the MongoDB client, all of them. And you'll have to tell the users, OK, if you want only MongoDB, then you have to exclude this dependency when installing a plugin. But people won't do that because we know they are lazy. So they will just use the default values, and they will end up with a class path with many things they don't need, right? Whereas if what you're doing is essentially the MongoDB support is a sub-plugin of your own plugin, then a user will have specifically say that he wants that plugin, right? When you have modules, then you get with smaller jar files, and it also helps you to reuse your build logic. So how do you do that? So how many of you know how to create a multi-module Gradle project? Raise your hands. It's a shocking number of 4 hands. So the answer to this question, how do you do this on Grails, is the same way you do with Gradle. So this is a Gradle thing. It's not a Grails thing. So you modularize a Grails project or a Grails plugin the same way you modularize a Spring Boot project or a Java application project or a Scala project or wherever you fancy. So this is a settings.gradle file on the root of your application or plugin in this case. And then you have like a different folders, right? So you might have like a core folder and then a domain folder, so on and so forth. So the settings.gradle is telling Gradle, OK, this is a multi-module project, and you have to include all these folders or projects as part of the build. So your root build.gradle file is everything which is common to all your plugins, right? So you will have, for instance, you can say, OK, for all projects, I want to apply the IDEA plugin, the Gradle plugin. All projects in this case is the root project and all the sub-projects, OK? However, the actual plugins, the actual modules are the sub-projects. So this is the closure, right? And then that's the place where you define everything which is common to all your plugins. So for instance, the group ID is likely to be going the same for all of them, right? Or the version. So you version them accordingly. You might have extension properties common for all of them, or common dependencies, or common repos or common dependencies, right? Or Gradle plugins you want to apply in all of them. So this is the way you do it. And then you end up with a build.gradle in the submodule, which is as simple as this one. There is a dependency management block that you have to repeat on all of them, because this doesn't work as part of the sub-project closure, but that's something you do and that's all. And the important thing is that the dependencies block. So you typically will have like a core plugin with the minimal part of the of your plugin, and then any optional dependency you need, you will add it here, right? So the result will be you will have like a core and the optional modules, and the user can install, for instance, the optional, the second one, and he will get the core one as well, because there is a compiled dependency on the core project. Things you might end up needing when working with modules. So one is, for instance, to aggregate the Java docs. The problem is that when you have a multi-module Gradle build, if you do Gradle RubyDoc or JavaDoc or whatever, you will get the RubyDoc, the API generated on every sub-project's build folder, right? So it will be like a core project /build /docs, whatever, and then optional project /build /docs, whatever, right? But it is not. If you want to publish that on a single place, it's very inconvenient. So this is a task that you can add to your root build.gradle that will essentially aggregate them all in a single place, right? And then you fetch that folder and you publish it over GitHub pages or whatever you want. Ah, okay. What else? So now imagine you've done a Grails plugin and you want to publish it. So this is not an easy task if you don't know how to do it, but that's why I'm here, to tell you how to do it. So there's two things you have to think about. Obviously, I'm speaking about public plugins. If it is an internal plugin that only your company is going to use it, then it's all about your company's Nexus repo or Artifactory repo. That's all. But if you're using a public plugin that you expect people to install it, then two things you might consider. So the snapshots publication, you need the Artifactory Gradle plugin for that, and they are published in Ojo, which is the open source version of JFrog, right? The guys who create Artifactory. And for the final releases, like the versions you expect end users to be using, they are published in Bintray. And there is a specific Gradle plugin for that, which is the Grails plugin publish, okay? Come on. So you first go to Bintray, and you create a repo in Bintray. So for instance, let's say you're creating a repo called plugins, right? It's a repo of type Maven because Bintray supports many things unrelated. So in that very moment, any user or any package published to this repo will be available under bintray.com/your-username/plugins, which is the name of the repo. Okay? The thing is that when Grails users will use your plugin, they are unlikely going to define an additional repo for that. So there is a way that your plugin is available as part of the standard repositories that are part of the build. But we are not there yet. So you have the bintray repo, and then you configure your publication. So for snapshots, this is the snippet you need for publishing them on JFrog. What I'm doing here is essentially, well, I'm publishing a sources jar in the java.jar file, and I'm specifying, well, a bunch of things like the URL and the repo key. Theoretically, you can publish releases as well on Ojo, but there's no point doing that. So only for these snapshots. And then username and password are Gradle properties that will be resolved in a different file. And for releases, there's a Grails publish block. All I'm telling you is Grails 3.1 related, because in 3.0 this was different. So in 3.0 there was a piece of build logic that you will apply from a URL. So you will say apply from and then GitHub URL, and you will have this publishing thing. But in Grails 3.1 this is different. So there are like proper Gradle plugins to do publishing. And there are two things here to consider. Well, a part of the metadata you have here, like for instance the license, the title, description, the developers, or things like that. There are two pieces of information we are providing. So one is the bintray information, and the other one is the plugin portal information. I'll go into that later. A couple of things you have to do in addition. So you have to define root project.name in your settings.gradle. This is crucial. This is really important. This is something you really have to do it. Actually, for everything you do in Gradle that you will publish in a public repository, you have to define the name of the project. Why? Because in Gradle, by default, the artifact ID, like the artifact name, is going to be the folder name, right? And you might want to use any clumsy name for your folder, like Grails-plugin, whatever, but we don't really care. So we provide a simple plugin name in root project.name, okay? There are many, let's say, types of plugin names you will see in the Grails 3 plugin portal. But the real way the good way to do it is that, because there's people using like or.grails plugins, colon, and then your plugin name. Don't do that. So if your plugin is Spring Security, then root project.name is Spring Security. That's all, right? And your group ID should be, or, for instance, if it's like an open source plugin, then it's or Grails plugins or com.mycompany.whatever, right? The other thing you have to do is to define credentials in your Gradle properties. Bintray username, bintray key, and the other one was the plugin portal user and plugin portal password. What is that thing? Well, how do you run this? There are two things. So for snapshot publishing, you'll run Artifactory publish, right? So this will use the Artifactory block definition in your build Gradle. And this is really useful if you publish your builds. So as part of your build pipeline, for instance, if you use Travis, you would like to have a final step as part of the build in such a way so that if the build is successful and all your tests are passing, you will likely publish this snapshot version into an Artifactory in Ojo. Because there might be the case that, for instance, there is people wanting to use a particular new feature or a particular bug fix, and they are eager to test it, but you're not keen on making a release at that point. So what you can say is, right, I made this commit, and as part of my build pipeline, it will get published in a new snapshot version in a matter of minutes. So he will be able to use that snapshot version immediately. And for releases, the two Gradle tasks you can use. So one is publish plugin that will publish the plugin on Bintray under your repo, right? The other one is notify plugin portal, because there are two plugin portals. So for Grails 3, which is the topic of the talk, once your packages are published under your Bintray repo, so for instance, bintray.com/alvaro/plugins, then you'll see your packages there. You'll see, for instance, Spring Security and the version of the package. Then once you have there, if you want to make your plugin available as part of the standard Grails repositories, then you have to go to bintray/Grails/plugins and then click include in my package. And then we will receive a request, and then we will approve it, likely, depending on who you are, and how much you're paying. When that's done, then will be like a proxy to say, right? So when someone is requesting a plugin which is not directly on this repo, it will try to look on the actual repository, which will be yours under your organization or username in Bintray, right? This is the URL for the Grails 3 plugin portal, and this is the URL for the Grails 2 plugin portal. So I told you there was two things you had to do, like a publish plugin and notify plugin portal. If you're creating a plugin which had a Grails 2 version, there might be the case that users, depending on which plugin portal are going to, they will find different versions. And this might lead to errors or mistakes, because they will see like a version on the Grails 2 plugin portal and a different one on the Grails 3 plugin portal. So this is notifying the Grails 2 plugin portal, the traditional one, which was called Grails Central portal, okay? So your credentials in the Grails 2 plugin portal is what you have there. And then you have a consistent version across all the portals. Some notes about testing. The actual testing of your plugin is something you will do depending on what you're doing. What I'm telling you is a particular approach you might want to follow. So let's say you have a plugin, but your plugin is configurable through different configuration values, and then you have like I don't know, different storages or different implementations. You have different strategies to use. So a part of the unit testing and integration testing, you will likely to have functional testing. So we'll likely have, as part of your build, the concept of I have to create an application, I want to install my plugin on it, I want to run a set of tests, and then if that passes, then good. But the thing is that there might be different configuration values you need to provide. So ideally, you would like to say, OK, now I want to do the same thing, but with different configuration values, right, to test all the possibilities. For the people that have been using or creating Grails 2 plugins in the past, this has been like spending hours and hours and hours messing with bash scripts and things like that. So my proposal is that you can use profiles for that. And this is really simple and clean. So the idea is that you can create a profile as a TCK for your plugin, right? So as part of your build, what you would do is, well, essentially this profile will have your plugin installed. This is obvious, right? Because you want newly created applications using this profile to have your plugin installed. So you don't have to do that. The profile will have your functional tests, right? Your TCK, all your tests inside. And for the different configuration values, you can have use features, right? There is an additional trick or tip that you have to follow. Because the profile.yaml is not capable of having variables. So this is the profile descriptor. This is the information that Grails takes to generate the application build.gradle, right? And one thing you can do is to create a template with a variable, and then you can do the same on the different features. Like, for instance, for GORM, this is the first feature set. And for GORM, for instance, I want the GORM module, as you can see here, right? And also want the Hibernate 4 plugin, Hibernate 4 build dependency, H2 at runtime dependency, and so on and so forth, with the variable as well. And this is a small snippet that you can use in your profile build.gradle to, let's say, generate the real profile descriptor and feature descriptor, right? In the skeleton of your profile, you will put all your tests, right, as you will have in your application. And also your resources, like any configuration values you want. So essentially, features will help you to have a different set of tests if you want, or different set of configuration values and resources and configuration files, etc. How you test them all? This is a small bash snippet. So you create an app, your profile. This is what Graham was saying before. So you can specify the Maven coordinates of a profile, right? Obviously, they have to be published on a public Maven repo with the plugin version. And for each of them, well, for each feature in the feature folders, then I'll create an application with that feature, and then move into the feature, run Gradle check, go back. And I do that for every single feature, right? I was planning to show you how is this done in the Spring Security REST plugin, but I'm out of time. The snippets I showed you, most of them are coming from the Spring Security REST plugin. It's everything published on GitHub, and this slide deck will be published as well soon after the talk. So that's all from me. That's a QR code with a small survey for you to provide feedback about this talk. And there's time for questions. So thank you.
That testing that you shown, I am not very happy with that. Have you tried to use the new Grails capabilities in the latest version about functional testing?
What do you mean?
Because you can, I think from Gradle 2.10 or something like that, you can specify a folder with a bit Gradle and Gradle open and run the application, and you can run any task, and you don't have to publish your plugin to Maven or something. It uses your source code.
I'm not familiar with what you're saying. What I know is the Gradle test kit, which
yes,
but the Gradle test kit is for Gradle plugins, not Grails plugin. You're mistaken.
But you can use with Grails is a Gradle application.
Yeah, it might be another approach, so that might work as well. But it's it's a bit weird to use the Gradle test kit, which is meant to be used to test Gradle plugins with Gradle tasks, like custom tasks you're creating to test a Grails plugin. But this is an option I'm presenting, so if you're happy with the test kit, then go for it.
Well, it's not easy, but I prefer to use my source code that have to install in a Maven repository and later.
So the example I showed to create an app with your custom profile, it doesn't have to be in a public repo, so you can do a Maven install and then or a publish to Maven local, to be precise, and that's all. It doesn't have to be published.
No, but for test your plugin, you have to publish that plugin.
No.
Okay.
Publish to Maven local, right? It's a Gradle, so Gradle will resolve first from your Maven local, right?
Okay.
So you publish to Maven local, and then you're done.
Okay, thank you.
That's all. Okay, thank you.
Thank you very much.